Welcome back. In the previous video, we discussed what Verilog HDL is and how it fundamentally differs from software programming languages. In this video, we will begin our formal journey into Verilog by looking at three very basic, but extremely important, topics. These are identifiers, comments, and logic values. Although these topics may appear simple, misunderstanding them leads to serious design and debugging problems later. Before designing hardware, we must name signals correctly, document our intent clearly, and understand how logic values behave in simulation and synthesis. Large FPGA designs often contain thousands of signals. If naming and documentation are poor, the design becomes difficult to understand, verify, and maintain. So we start with discipline, right from the beginning. Let us begin with identifiers. An identifier is simply a name used to represent something in Verilog. Identifiers are used to name modules, ports, signals, registers, parameters, and many other objects. Just like variable names in C or Python, identifiers help us refer to hardware elements. However, in Verilog, identifiers represent physical signals and structures, not abstract variables. Rules for identifiers. Verilog has clear rules for valid identifiers. An identifier must begin with a letter, uppercase or lowercase, or an underscore. It may contain letters, digits, and underscores. It cannot begin with a digit. Identifiers are case-sensitive. This means that data, and data are three different identifiers. Identifiers must not use Verilog reserved keywords such as module, input, wire, or always. In professional designs, identifiers should be meaningful and descriptive. A good identifier tells you what the signal represents, even without comments. Next, let us discuss comments. Comments are used to explain the intent of the code. They are ignored by both the simulator and the synthesizer. However, they are extremely important for humans. Verilog supports two types of comments. The first is the single-line comment, which begins with two forward slashes. Everything after these slashes, until the end of the line, is treated as a comment. Then, the second is the multi-line or block comment, which starts with a slash asterisk and ends with an asterisk slash. This type of comment can span multiple lines. Comments should explain why something is done, not just what is done. In hardware design, comments are particularly useful to explain assumptions, timing intent, and design decisions. Now we move to one of the most important conceptual topics in Verilog, logic values. Unlike software languages, Verilog supports more than just 0 and 1. Verilog supports four primary logic values. The first is logic 0, represented by 0. The second is logic 1, represented by 1. The third value is x, which represents an unknown value. An x does not mean an error. It indicates that the simulator cannot determine whether the value is 0 or 1. This often occurs due to uninitialized signals, conflicting drivers, or incomplete assignments. The fourth value is z, which represents high impedance. This is used to model tri-state behavior, such as shared buses. In real hardware, z corresponds to a disconnected output. In simulation, it helps us detect bus contention and improper driving. Ignoring x and z values during simulation can hide serious design flaws. A clean waveform with only zeros and ones is usually a sign of good design discipline. It is important to remember that some logic values exist primarily for simulation. For example, x is extremely useful for catching errors during verification. However, real hardware never operates with an x value. Therefore, simulation is a powerful diagnostic tool, but it must be interpreted correctly. To summarize this video, identifiers define how we name hardware. Comments define how we communicate intent. And logic values define how signals behave in simulation and synthesis. These are small concepts, but they form the foundation of everything that follows. In the next video, we will move on to Verilog data types and understand the difference between nets and variables. Please review these basics carefully. They will be used in every example from now on. Thank you.